Welcome to our third presentation, technical grower talk on the quality control that takes place at Berger. Quality control and Berger go hand in hand. It's one of the most important things we do at Berger is the quality control on our products, not only on our final products, but any component that we add to our mix goes through certain quality control depending on what that component is. Everything that is non-conform, which means that doesn't fall within the specifications that we've given to that product, will not be used in our growing media, or the growing media simply won't be sold to our customers. Every non-conformity is seen as an opportunity for us to improve, either on the production side or through the suppliers that we use. Our goal is really to provide customers with consistent high quality products every time. So Berger's been ISO certified since 1996. Since then, we've done a lot of improvements. It's always in constant improvement. The ISO certification covers the peat production, also the components. So we'll go through that a little bit right here. So during our harvest season, the peat is classified according to its density, the particle size, and the overall quality of the peat. So that's done in the field as we harvest. It's something that's done constantly during the harvest season. We actually have an employee whose responsibility is to go through the field every day and to actually reevaluate the grade of the peat that's being harvested in each different section of the bogs. To produce the growing media, we actually bale the peat as much as possible out in during the harvest season. So different grades of peat are actually brought to the factory in different hoppers and are blended together to achieve the grades of peat that we want, either the BP coarse or the BP fine, or anything in between. The baled peat is then sieved a second time before it gets used to manufacture the mix. So that means that we have even more consistency and we remove even more sticks from the product. And some field peat can actually be added during production, but it's typically a very small percentage. But it's, obviously it still gets sieved, and it always is blended with the baled peat to get that consistent product. All the blending that we do blending from different harvesting sites together. We do blending within the same site to get the grades that we want. And even for the mix, we actually bring in peat from New Brunswick to blend in with our Quebec peat to get really a good consistency in terms of our products. Because the products that we manufacture, the BM6 that comes out of our New Brunswick manufacturing facility, we want it to be identical to the product that's manufactured in Quebec or even in Texas. So we have a lot of different components that we add at Berger. For instance, the perlite, the vermiculite, wood fiber, core, redwood out of our California facility. So all those different components are either manufactured by Berger, like the perlite, the vermiculite, our compost, or they're purchased, and for every material that we purchase or we manufacture, we have a whole bunch of different tests that we do to make sure that they're adequate and that they can be used for to manufacture our mixes. So a characterization is done for every batch. So if we're manufacturing a batch of perlite, we'll be testing that batch of perlite throughout the production. If we're purchasing a load of wood fiber, for instance, we're testing that wood fiber for different characteristics to make sure that it's good to be used in our growing media and that we accept that batch. So we actually use those results to adjust our recipes during the production to make sure that we do get that consistency. That allows us to compensate for any slight differences there might be between batches of components. So just to give an example, for example, the BM6, the peat moss that we're using, we're actually testing particle size, density, water content, and stick content. So we've got examples of those reports right here. And then we're adding also perlite. So we've got also the test that we do on our perlite, particle size, expansion factor, the dolomitic, calcitic line. Those are different tests that are done in our laboratory to make sure that we verify the neutralizing power of that lime, the carbonate content, particle size, water content, efficiency. The different solid fertilizers that we use. We're using calcium nitrate, magnesium sulfate, chelated iron, potassium nitrate, triple superphosphate, and the FTE, the fritted trace elements. All of those are tested as well. And from those solid fertilizers, certain fertilizers are added in the liquid form. So we prepare liquid batches of calcium nitrate, magnesium sulfate, and also the chelated iron. And those batches are actually tested as well to make sure that the content of the different nutrients that we're adding through those batches are within spec. Even our wetting agent that we add, we dilute that because it's a very viscous product. We have to dilute it in water, and we are always verifying each batch to make sure that we're within the concentration that we were preparing. So all those reports are actually very important for us when we prepare the recipe and we actually manufacture the final product. We also keep samples of all the batches we receive. We keep those in a warehouse so that if ever there's any issues with the production, we can go back and actually test those components. So when we're preparing the recipes, we'll actually look at the quality control from the previous productions of that product. We're also looking at the quality control for the components that we'll be using to make the final product, and also any special requests that we have from customers. If they want a different pH, if they want us to add other components such as actinoiron or root shields. So all that's taken into account to prepare the recipe. And for each production, the recipe is reviewed and corrected every time. We also do several tests during the production, and that's really what allows us to make real-time adjustments during production. So if the pH starts to get a little bit too high, we're readjusting the lime content during production. So we have several sampling that are done during production. As I said, we have a pH 1 minute and 20 minute that's done. The EC is also tested, the particle size and the root content, the density and moisture, and the wettability. So all those are done at the factory because they are elements that we can control and readjust during production. So we have a specific acceptance range for all of these elements, and if ever they fall out of those specs, as soon as it gets close to the upper or lower, we have very clear visual indications in our consoles, and that allows our employees at the factory to make the readjustments easily. So all those adjustments are made throughout the production, and we're really trying to hit the middle of that target. So that the pH allows us to adjust the lime, the EC will be the fertilizer feed, the particle size and root content. We'll make adjustments through our sieving system, adjusting the speed of the sieving system. Density and moisture will actually be the water feed, and the wettability will be the wetting agent feed. So this is just a summary of the testing that's done during production, but we also have a lot of testing that's done after the production. So once the product's manufactured, certain samples are sent to our laboratory, and from those samples we'll test the 1-day, 7-day, and 30-day pH. We're also testing the EC, the particle size and root content. We do an SME analysis, water content, and density. So we'll pull a sample for approximately every 100 cubic foot of material that we manufacture. So for production of BM6, which can take maybe, let's say we're producing for 4 hours at 120 cubic feet per minute, that equates to roughly around 20 samples that we'll analyze with those characteristics. So that allows us to really, the SME actually, these are the elements that we test through the SME, nitrates, ammonium, phosphorus, potassium, and all the other major or minor elements. We do about 125,000 incubated pH tests per year and 22,500 SME tests. And that's just for quality control. That doesn't include what we also do for customers if they send us samples. So All those tests that we do, we can report that in a final inspection report like this. So if you order a batch of BM6 or BM4 or whatever, we can actually send these reports to you so you can take a look at the results that we got for instance, the pH, the particle size, the water content, to adjust the water content before potting. So these are all details that can be provided to customers. And this is actually what we'll use to authorize or reject the product. So we have acceptance ranges for all these elements, and if the results fall out of those acceptance ranges, the product will be rejected. So just a summary of the testing that's done post-production, but also for those post-production samples, we retain warehouse samples as well. So if there's any issues with customers growing in their greenhouse, we can always go back and pull those samples and do further tests if necessary. We also have quality control for our packaging to make sure that the volume that we put into our bales is the correct volume, the volume that we're selling to our customers. And also, before shipping, each bale or skyscraper will be evaluated for the aesthetic appearance. So if we're storing bales for a while, if any damage has happened to those bales during storage, those bales will either be rewrapped or they simply won't be sold. But we're verifying the weight of the bags, the yield, how much volume is per bag, and also the dimensions to make sure that we're within spec there. The machinery, for instance, for the skyscrapers, the machinery has a certain dimension, and if the skyscraper is too tall, it won't fit into the machine, then it's no use to the customer. So another extra step that we do at Berger is for skyscrapers. We have our method of measuring the yield. So we measure a cubic foot at the factory, we weigh the skid, and from that value we are able to determine the volume per skyscraper. But to make sure that that volume that we measure at the factory is actually the same as the usable volume, we actually have a bale breaker machine in our factory, and we actually process many Berger skyscrapers throughout the year to counter verify those values. So we count the amount of pots that we produce with the given product and equate that to the volume that we measure at our factory. So it's an automated potting line that we have that we've actually modified to be able to count a lot more pots than our customers can actually do, because it fills up and empties itself by itself. Everything is counted automatically. So we are really relentless in our constant pursuit to improve. So we also have an efficient complaint management system. It's a system called QWeb, which actually is used to basically gather all the information for a complaint. So if we have a complaint from a customer, we can actually enter it into the system, pull all the data that's for the production, for instance, any pictures that we've gotten from the customers, any samples that were sent, any tests that we've done. All that is brought into one specific system, which is QWeb, and that allows us to investigate the situation, and if necessary we can send a grower advisor to the greenhouse to investigate as well, to help figure out what the issue is and find a solution. So we'll take a look at the final inspection reports for the production, we'll look at the retained warehouse samples, we'll also do an investigation at the factory. We'll do an analysis of customer samples, as I said, water, used media, tissue, send visits from our grower advisor, and that's really thanks to our complete traceability system. We can pull all the information we need from just knowing who the customer was, when he got that load delivered. All that information is available through our computer system. This is a summary, just a summary diagram of all the quality control that's done at Berger. So we see the quality control that's done out in the field, directly in the bog. We have the quality control that's done in the piled peat that's out in the bog. Once it's brought into the factory, the peat is actually blended together, it's sieved, and we have quality control on the product that comes out, so we can make readjustments on the sieving system. And then that's packaged as our BP products, the Berger peat products. And Those are stored outside, and once we need them for our mix production, we actually bring them into the factory. We can blend peat from different sites or from within the same sites, different grades of peat, and then we add all the different components, whether it's solid components like peat, like perlite or vermiculite, or our fertilizers, our wetting agent, and then we have quality control that's done on the line and the quality control that's done on the final product in our labs. Quality control is also done in the packaging systems, and then from that we get the authorization from the lab for either the peat or the mix to get shipped to our customers. So this system's been built for many years. I mean, we started off with certain quality control, and with the years that have gone by, we've always improved that system, and it allows us to really provide growers with uniform products, superior quality, regardless of where we're producing it or when we're producing it. So coupled with our renowned product traceability and our technical services support, we can definitely efficiently pinpoint the source of any issues a customer is having, and implement effective solutions to correct or prevent future problems.